Enough of doing the coding and the projects in Verilog. Now we are going to play a game. Yes, everyone's favorite game, that is the snake game. But we have to create this game before we start playing the game because we are the creators. Okay, so before we move on to designing this game, let us first know what is going to happen in the game. So first we are going to have the snake, we are going to have the fruit, we are going to have the direction where the snake is going to move in right, left, up and down direction, and then we are going to have color, that is red, yellow and green, and we are going to have one border which defines where the snake should be moving and it should not go off border. So what is happening in this game is the snake is going to move in any of the direction which was mentioned earlier, right, left, up and down, and to eat the fruit, and the fruit will be generated randomly at any place inside the border. And then if the snake eats the fruit, the yellow color will be generated, and if it touches the border or if it touches its own body, the red color will be generated, or if the snake reaches its maximum length, you have won the game. So let's just go into the designing part, guys. Okay, so now we will see the design part of the game. At first we have to declare the module here, and then we have to give input and output pins. The input, clock and reset, and the output pin, snake in x-axis, snake in y-axis, fruit in x, fruit in y-axis, then the direction and the color RYG. After giving that, we will define the parameters, that is the width and the height. This too defines the border of the frame, and then we will have the snake initial length equal to 1 and the maximum length equal to 2159, and then we will define the directions here, that is the right, left, down, up, which is a 2-bit register. And then we will have the initial begin here. This block means like when the game is going to get started, it will define the initial position of the snake with respect to the frame and the direction where it is going to move, and the fruit, like it is going to get generated randomly. So the snake in x-axis is equal to width by 2, and snake in y-axis it is going to be height by 2, which means it is going to be at the center of the frame, and the direction, it is going to move in the left direction, and the fruit is going to get generated randomly. And then we will have a positive edge clock here. That means when the clock is active or high, the reset is going to begin. That is, when the reset is not going to happen, it will take the direction case where the right equal to snake in x-axis, it is going to increment to the 1, and for the left direction, the snake in x-axis, it is going to get decrement, and for the up, the snake in y-axis, it is incremented to the 1, and for the down, it is going to get decremented by 1 in y-axis. After that, we are going to define conditions here. At first I have already told the set of conditions, like when a snake eats the fruit, when the snake touches the border or touches its own self, or when the snake like reaches its maximum length. So for the first condition, when the snake eats the fruit, the yellow color will be displayed. So how the snake in x-axis will be equal to fruit in x-axis, and the snake in y-axis equal to fruit in y-axis, which means that the position of the snake the position of the snake and the position of the fruit, it is going to be same. At that time, the yellow color will be going to get generated here. Like see, it is a 8-bit register, so all 1. And the snake in y-axis, which defines the length of the snake, it is going to get incremented by 1. And for the fruit in x-axis and y-axis, it is going to get generated randomly. And then if the snake touches the border or itself, at that time, when the snake position and the fruit position are not equal, for that case these two conditions come. So when the snake in x-axis equal to the width, or the snake in y-axis equal to the height, that means when the snake touches the border of the frame, at that time the red color is going to get generated, which is going to display snake touch the border. or else if the snake touches its own body, like the snake in x-axis denotes its head and snake in y-axis it denotes its own tail. So when these two are going to collide with each other, at that time red color is going to get generated and it is going to display snake touches itself. And if these two conditions satisfy, whatever the two conditions satisfy, it will also display game over. And then when the snake reaches its maximum length, like after eating the fruits, it is incremented by 1. So when the snake reaches its maximum length, at that time the color green is going to get generated along with the message congratulations for winning. And for the default condition here, so sometimes when the snake is not going to eat the fruit, it misses. At that time it is going to move in the right direction, it is going to get redirected to the right direction, and the fruit is going to get generated randomly as usual, and it will display missed the fruit. Now we will see the test bench for it. The test bench is we have to declare the module name here first, that is Snake Game Verilog TV, and then the parameter, that is the clock period, which is equal to 10, and then the input and output as register and wire. After that we will declare the unit, that is under unit time, where the input value is going to get examined by the output values, and then we will have the clock toggle at every clock period by 2, and then we will have the initial set, that is the reset equal to 1 and 100. After 100 unit of time it is going to get reset to 0, and after that we will have the display here for the snake position and the fruit position and at what direction and color it is going to get generated. So the design part is over guys, but the creating part is not yet over. So what we are going to do is we have to do the FPGA implementation on this so we can actually play the game. So what we are going to do now is we will wait for the next video. In the next video, I am going to talk about the FPGA implementation, like how we can implement this design on FPGA so we can actually play the game, and it will be fun guys, it will be really fun. Stay tuned for this video. But before doing that, let's just see how the waveform will look, but remember that's not the final part yet. Okay, so see, this is how our waveform is going to look like. So the creating part is not yet over guys, so stay tuned for the next video where I'm going to do the FPGA implementation for this game so that you and me, we both can together play the game of Snake, which is our favorite game. I hope you like this video guys. If you like this video, like, share and subscribe, and don't forget to hit the bell icon below so you can be updated with my videos. And more importantly, we have to play the game, so be updated.